Hi, in this video, we will learn about finding the inverse of a non-singular matrix using the equation AB equal to Ki. Please do take note that the A inverse is not referring to 1 over A. A inverse means the inverse matrix. There are a few properties of inverse matrix that you have to know. The first one is A inverse, and then you inverse that A inverse matrix back, you will get the original matrix A. Next property, A transpose being inverse is equal to A inverse being transposed. The third one, A times B inverse is equal to B inverse times A inverse. Do take note that the matrices switch. Here, matrix A first, and then matrix B is the last one. But when you inverse the matrix B will go first here, multiplied with matrix A. And the last property is the determinant of A inverse is equal to 1 over the determinant of A. Besides those four properties, these are some interesting properties that you have to know. A multiplied with A inverse is equal to the identity matrix. A inverse multiplied with A matrix is equal to the identity matrix as well. A multiplied with the identity matrix, you will get matrix A. It will not change the values. A inverse multiplied with I matrix is equal to A inverse as well. So any matrix multiplied with identity matrix is just that matrix again. So when we have the equation AB equal to Ki, and then we want to find the inverse matrix A, we can just simply add A inverse on the left hand side of matrix A. And if it's adding A inverse on the left hand side, that means we also have to add in A inverse on the left side of this right hand side, right next to I. Why not writing A inverse in front of the K? Well, that's because K is just a scalar. We can simply write the scalar first and then matrices multiply with matrices. Next, A inverse multiplied with A is equal to I. And then A inverse multiplied with I is just A inverse. So on the left hand side, you still have B here, equal sign, and you still have K here. Next, what is identity matrix multiplied with the B matrix? It's just the B matrix, because identity multiplied with any matrices is just equal to that matrix again. And on the right side, we still have K multiplied with A inverse. So what is A inverse? Write A inverse as the subject, and then since K is just a scalar, you can bring it to the left, divide 1 with K. So 1 over K can be multiplied with matrix B. That's A inverse. That's how we get this formula to find A inverse by using this equation. Let's look at example on how to apply the formula. First example, if A and B are matrices as given, find AB, hence deduce A inverse. Write A next to B, multiply them together. Remember, to multiply matrices is the row times with the column and then adding the values up. So the first one is just 2 multiplied with 3 plus with 5 multiplied with negative 1. Next, we want to find the value here, which is in the first row and second column. So we have to delete the other rows. Look at the first row and second column and multiply the values. 2 times negative 5 is, and then plus with 5 times 2, and so on. Doing the same for the next element, 1 times 3 plus with 3 times negative 1, and lastly 1 times negative 5 plus 3 times 2. Solve the values and you find your AB matrix. Notice that this AB matrix is equal to 1 0 0 1. And what is this matrix? It's a very popular matrix which we call as identity matrix. So this is equal to the identity matrix. The next part of the equation wants us to deduce A inverse. Hence, deduce A inverse. Whenever we see the word hence, that means we have to use the information given before, which is the information about A multiplied with B. So how to find A inverse? By using this information, which is AB equal to I. AB here is equal to this identity matrix. Since AB is equal to the identity matrix, to find A inverse, we can just write A inverse multiplied on the left hand side and then multiplying it on the left hand side of the right equation, and then A inverse multiplied with A is equal to I multiplied with B. A inverse multiplied with I is just A inverse, and then I multiplied with B is just B. So that's how you get A inverse equal to B. So just write down the matrix B to find your A inverse. If you try to find the A inverse matrix by using the formula 1 over the determinant and then the transpose adjoint D negative, B negative, C and A, then your answer is wrong. You will not get any marks for that question. Let's look at this next example. This is a 3 by 3 matrix. We want to find AB and hence deduce A inverse. Be careful with the word hence. This means we have to use the information that we get from multiplying A with B to find A inverse. You cannot simply use the formula of a joint matrix to find A inverse. Write the matrix A next to B, multiply the elements one by one. Remember, to multiply the elements, look at the first row and the first column, multiplying the elements one by one, 1 times 1, plus with 2 times negative 10, plus with 3 times 7. And then, looking at the next column, this is the element in the first row and second column. That's why we just look at the first row and second column. So here, multiply the elements one by one, starting with 1 times 1 plus 2 times 4 plus 3 times negative 3, and so on. Do for the rest one by one until you get the final matrix of A times B. Notice that A multiplied with B is equal to 2 0 0 0 2 0 0 0 2. This looks like an identity matrix but with 2 in the middle. So since AB is equal to 2 0 0 0 2 0 0 0 2, this looks like 2 multiplied with the identity matrix. Why do we have to change this AB matrix to be 2I? Well, that's because you want to answer the next question, hence deduce A inverse. This means we cannot use the formula of A inverse equal to 1 over determinant adjoint matrix A. You cannot use this formula because of the word hence. So you have to use this information, which is AB equal to 2I. So once you know that AB is equal to 2I, you can simply use this formula that I have proven before. A inverse is equal to 1 over K multiplied with the matrix B. So this is just A inverse equal to 1 over 2 multiplied with B, because this is our K as the scalar. So according to the formula, this is 1 over K. You can also find it by using this method, putting A inverse on the left hand side and also on the left hand side here, and then A inverse multiplied with A is equal to I, identity matrix, and this is just A inverse multiplied with I, which is A inverse, and then I matrix multiplied with B is just B, because identity matrix multiplied with any matrix is just that matrix. And then just bring your scalar to the left hand side. It will be 1 over 2 multiplied with B, which is just the same. Then substitute your matrix B, and that's your answer. Example 3. Let's say we have this matrix A. Find the values m and n such that a squared plus ma plus ni is equal to 0, where I is a 3 by 3 identity matrix and 0 is a 0 matrix. Use this relation to obtain A inverse. Write your matrix A. A squared means we have to multiply matrix A with matrix A. So write A and A next to each other. M is just a scalar multiplied with matrix A, plus n is just a scalar multiplied with the matrix I. Remember, identity matrix looks like this, and it's a 3 by 3 matrix. 0 is just a 0 matrix with all zeros. After you have multiplied A with A, that will be your answer, and then write the rest next to it. Now, you want to find the values of m and n. You can choose any element, and let's say if I choose the element in the first row and second column, so I have to choose the first row and second column as well for this matrix and the rest. Now we can just compare the values. 7 plus m plus 0 is equal to 0. And why did I choose this first row and second column? Well, that's because it makes my life easier to solve the question, since n times 0 is just 0. If I choose the first row and first column, I will still have the value n. So from here, I will get my answer m as equal to -7. Next, to find n, I can choose the second row and second column element. So choose the same element for the other matrices. This is just 11 plus m times 3 plus n times 1 equal to 0. Since you know your answer for m is -7, substitute it in, and then you will find your answer for n. To find the inverse of A, this is our equation. And then we have to multiply each term by A inverse. So choose one side. Let's say you want to multiply with A inverse on the right side of each of the terms. So put A inverse on the right side of each of the terms. Note that the multiplication with A inverse is consistent, whether to the left or right hand side of each term. Why this is important? Well, that's because the order of matrices are very important, since A multiplied with B might not equal to B multiplied with A. So the order really matters for matrix multiplication. Now to solve this equation, A squared is simply A times A, and then we have times with A inverse. Remember that A inverse multiplied with A times A inverse is just the identity matrix. So this will be A multiplied with I. And then here, A meets A inverse. So this will also be I. When I meets A inverse, we will not change the value of that matrix, so it will just be A inverse. And here, 0 matrix multiplied with any matrix will just be 0. So that's where I get AI minus 7i plus 10 A inverse equal to 0. Rearrange the equation so that A inverse as the subject, and then bring 10 to the right side, so it'll be 1 over 10 multiplied with 7i minus A. Well, what is the A inverse matrix? You know I is just the identity matrix, and just multiply the scalar 7 into the identity matrix, and then minus with matrix A. Subtract these two matrices, and then multiply with the scalar 1 over 10. That's your final answer. What about example 4? We have these three matrices. Find A times B plus C and A times C. Hence, find the inverse of matrix A. Write down your matrix A and then B plus C in the bracket. So you have to solve the matrices in the bracket first. That means we have to add these two matrices first. Add those elements one by one. Negative 3 plus 5 is 2. Negative 4 plus negative 7 is negative 11. 5 plus negative 1 is 4, and so on. Next, just multiply these two matrices together, which is just the row multiplied with the columns, looking at the elements one by one. 1 times 2 plus 7 times 7 plus 3 times negative 16. And then looking at the second column, this is 1 times negative 11 plus 7 times negative 13 plus 3 times 34. Your answer is 0, and so on. So what is matrix AC? Multiply these two matrices together, and your answer is 7, 0, 0, 0, 7, 0, 0, 0, 7. Hence, find the inverse of matrix A. Since we know that A multiplied with B plus C is equal to that, and this equation does not have the form of AB equal to KI. So we cannot use this information to find the matrix, the inverse matrix of A. What about the next answer that we have obtained, which is AC? A times C is equal to this matrix, and this matrix does look like the form AB equal to KI. It can be written as 7 multiplied with the identity matrix. So you can write AC as 7 multiplied with I matrix. So how to find the A inverse? Remember, you can use the formula. A inverse is equal to 1 over K times B. So now you don't have B, but you have C. So it's just 1 over 7 multiplied with matrix C. Write your matrix C and multiply with the scalar 1 over 7. And that will be your final answer. Look at example 5. If A is as given, show that A squared is equal to negative 3i and A cubed is equal to negative 3a. Hence, find A inverse and A to the power 4. What is A squared? A squared, remember, means A multiplied with A. It's not the square of each of the elements. So you have to write matrix A next to matrix A and multiply the rows and columns. Multiply the elements one by one, and that will be your answer. Since you want to show that A squared is equal to negative 3i, we have to show that this is equal to negative 3i. Shown. Next question wants us to show that A power 3 is equal to negative 3a. How to show that? We can separate A power 3 to be A squared times with A. And from the previous question, we know what is the value of A squared. A squared is just negative 3i. And then replacing A squared there, remember the order matters, so write it in front, multiply with A, And then I, identity matrix multiplied with any matrix, is just that matrix. So you get -3 multiplied with matrix A. You have shown the equation. Last question. Hence, find A inverse and A power 4. So to find A inverse, you have to use the information given from the previous question. So what we have obtained previously is A squared equal to -3i. We have to use this information because it has the form of AB equal to KI. What's important is this identity matrix is there. Once you see the identity matrix is there and there's a scalar, we can simply use the formula A inverse equal to 1 over K B. So our K now is -3, and then our B is not B, but it's A, since this is A multiplied with A. So A inverse is equal to -1 over 3 multiplied with matrix A. Substitute your matrix A there, and then multiply with your scalar -1 over 3. So what is A power 4? The question says, hence, deduce what is A power 4. So we have to use the previous solution. So from the previous solution, we know that A power 3 is equal to -3a. And we can separate A power 4 to be A power 3 multiplied with A. So from the previous solution, A power 3 is equal to -3a multiplied with the matrix A. And now, A multiplied with A is just A squared. And we also know what the answer for A squared from the previous solution, which is -3i. Substitute it in, multiply -3 with -3, and the answer is 9i. Substitute your matrix identity and put the scalar in. That's your answer for A power 4 matrix. Thank you for watching.